All right, problem 50 of chapter 14. We have two pipes that are 30 meters long, and we got a total distance of 110 meters. And we know that when we pump water in at 2.5 meters per second on one side, it comes out on the other side at 2.5 meters per second. So we stick a dye in. The issue is we don't know the size of the middle of the pipe. So we stick a dye in and find out it takes 88.8 seconds to go all the way through. So that tells us that the velocity that's going through with is 88 point, whoop, is 110 meters divided by 88.8 seconds, right? 110 divided by 88.8, and so that 110 divided by 88.8, so we got a total velocity of 1.24 meters per second is how fast it's making it through. So the big question is, how fast or how big is the pipe in the middle, right? So we know at 2.5 meters per second, it takes the time to go through A and B. I'll just put them together, right? Time it takes to go through A and B is going to be, they are total 60 meters long divided by 2.5 meters per second, right? So 60 meters divided by 2.5, 60 divided by 2.5, so no, it takes 24 seconds, right? It takes 24 seconds to go through those two pieces of the pipe. The length that's left is 50 meters, right? 50 meters. And it goes through the 50 meters in 88.8 minus 24 seconds, all right? Equals 50 divided by 88.8 minus 24 is 0.77. 0.77 meters per second is the velocity through the center piece, right? Center. The velocity we're going through in the center. Okay. What is the average radius of the pipe within the hill? The radius on each side is 2 centimeters, right? Okay. Radius on each side is 2 centimeters. And so what we're going to use is the flow rate. Flow rate R is the area times the velocity, right? And that's got to be a constant throughout the pipe. So on one side it's pi r squared times I'll do RA squared, right, times VA, right? And then in the middle it has to be pi r center squared times V center. Now we have everything here. So we know that V velocity in the center, or the radius at the center, squared, average radius at center squared, is radius at part A squared times velocity at part A divided by velocity at the center. All right, and so to get R center, the average for radius in the middle, we just need the square root of all this. Okay. RA is 2.0 centimeters, right? Okay. Equals square root of 2.0 squared times 2.5 meters per second divided by 0.77 meters per second. And I get 3.6 centimeters. So 3.6 centimeters is the average radius of the pipe in the middle that's underneath the hill. And that's it for problem 50.